Okay, so picking up where we left off with last time, this is June 2017, variant 5.1, question number 1. In the last video we did part B, C, D, and E. So now we're gonna start with part F. Okay. So part F says one of the results is anomalous. Anomalous is like, a result which is an anomaly, kind of like a weird one. So this occurred because the student took the thermometer out of the solution and then replaced it just before the reading was taken. So what he did was, this is the beaker, for example. So he put the thermometer in, he took it out, and then he put it back in again. Okay, so that was the thing which led to this anomalous or weird reading. So they say the time at which the anomalous reading was taken was dash minutes, and we need to figure this part out. So what we're gonna do is that we're simply gonna go and look at our graph. So I'm just gonna clean this graph a bit. It looks really messy. Okay. So over here in this one, we see that it's a straight line. There are no weird results. Now if you look at this thing, so look at this pattern. Doesn't it look like it's almost in a line? Okay, like it's not all of these crosses. They're like kind of close to and near to each other. So which cross or result is the one that is the farthest away from this general cooling curve? So yes, it's kind of obvious, isn't it? It's this result, this guy over here. And if we go actually, it's a horrible line. If you actually like go and see so it's somewhere over here. Sorry. Okay, this is like the time. It's between 7 and 8. So if you like use a scale and then properly do this, that's actually not this. It's not between 7 and 8. If we use a scale and we do this properly, so you'll find that the time is somewhere between 8 and 9. And the exact, accurate, correct answer is 8.5 minutes. So this is 8.5 minutes. Now they say that explain why these actions led to the anomalous point. So we can write two things over here. We can write either this, or we can write the second thing, which is this. We can write okay. not enough time to reach solution temperature. Not enough time to reach solution. Sorry about that. Not enough time to reach solution temperature, and or you can write it takes time for the thermometer. To reach equilibrium with the water temperature. Okay, so we're done with part F as well. We said that the anomalous reading is 8.5 minutes, and the reason for this is either that it wasn't enough time to reach the solution temperature, or it takes time for the thermometer to reach equilibrium with the water temperature. So we're done with part F as well. We're gonna move on to part G. And this explains why the stirring of the mixture is more reliable. So why it is more reliable? Because then the calcium chloride will dissolve more quickly and more, you could say, perfectly with the water. So the temperature rise that you'll get would be more accurate. So the answer for this is ensure uniformity of heating, so that the heat which is evolved from this reaction of calcium chloride dissolving water, it is spread evenly throughout the whole of the solution, so you have uniform heating. Okay, so now we're done with part G as well. Let's move on to part H. Anhydrous calcium chloride is classified as a moderate health hazard. It is an irritant. So, I mean, if it spills, okay, or you touch it, or it gets in your eyes or anything, so it's going to be irritating. So they say apart from wearing eye protection, state one other relevant safety precaution that the student should have taken. So what you can do is that you can wear gloves, so that even if it spills on your hands or anything, you're wearing gloves, so obviously you're not going to feel irritation. And or you can wear a face mask, so that if it falls or spills or it somehow gets on your face or maybe in your mouth, so none of those things could happen if you're wearing a mask. So we have two things, we have this and this. We have wear gloves and we have